Okay guys, today we're going to focus on just one basic skill, which you're going to see on your benchmark, so it's actually super important. Super important. So make sure that everyone's attention is focused right here. Talking to you, Vancy. All right guys, what we're going to talk about today is a reminder of when I say how many times greater something is. So whenever I say how many times greater, you should immediately say, oh, Miss Abel, you're talking about division, because obviously I am. So if I were to say how many times greater is 40 than 5, what I'm talking about is division. And of course, the large number always goes on top. 40 divided by 5 is going to give me 8. So 40 is 8 times bigger than 5. Let's do another example. All right, here's our second example. How many times greater is 12 than 9? Again, whenever I hear how many times greater, that obviously always means division. Always. Forever and ever, amen. So I'm going to put 12 and I'm going to divide it by 9. If I divide 12 by 9, I'm going to come out with 1.33 repeating. So 12 is 1.3 repeating times greater than 9. All right, guys, this seems like a really simple skill. However, it is going to come up on your benchmark, so it's going to be ingrained in our practice today. Take it super seriously. Today's your last day to practice for your benchmark, so let's make it count.
All right, guys, let's look at this one. We are gonna have one exactly like this on our benchmark. I know it seems kind of random that we're covering this just like the day before the benchmark, but I want you guys to be able to understand how systems work conceptually. So let's just read it. Mr. Heron is selling SciTech swag in the form of golf shirts and hats at a baseball game to raise money for the school. The table below shows the number of golf shirts and hats in each of the last few orders. The total costs of A and B are given. Each golf shirt has the same cost and each hat has the same cost. So again, if I look at order A, I see that this person has bought 2 hats and 1 golf shirt, and that's cost $42. Then if I look at order B, they've bought 3 hats, 1 golf shirt, and that's been $48. And then order C, 4 hats, 2 golf shirts, and I don't know how much that costs. That's one of the things I want to answer. So the systems of equations shown can be used to represent the situation. So if I look at my first equation, I see that 2 and 1 match up to equal $42. So literally that's just put it together across the table. Same thing with my second equation. 3x plus y, 3x plus y equals 48. Part A is asking me, what is the total cost of 1 hat and 1 golf shirt? So what I need to do is I need to solve this systems of equations and find the solution. So let's go ahead and do that. If I have 2x plus y equals 42 and 3x plus y equals 48, this is just going to be like math intervention. I'm going to use substitution. I need to get one of these equations to where y is by itself. So I'm just going to choose this second one. And I'm going to get y by itself by subtracting 3x from both sides. If I do that, I'm left with y equals 48 minus 3x. Now I have 3 equations. Now what I'm going to do with this is I'm going to take this equation, I'm going to substitute it in for y in my first equation. So I have 2x plus pocket, big pocket, and I'm going to fill in y with 48 minus 3x equals 42. Again, all I did was I took this, I plugged it in for y in my second equation. That's going to leave me with 2x plus 48 minus 3x equals 42. I have like terms here, 2x and negative 3x. I can combine those to make negative x or negative 1x. I haven't used my 48, so I'm going to bring that down. If I subtract 48 from both sides, this should be simple. I'm going to be left with negative x equals negative 6. 42 minus 48 is negative 6. Now, I'm not done because I have this pesky negative here. So I need to divide by negative 1 on both sides. If I do that, I'm left with x equals 6. So for my solution set of x and y, I already have half of it. I already know that x equals 6. Now I need to figure out y. So I'm going to take x equals 6. I'm going to plug it in to one of my original equations. So stay with me. We'll just do the first one. I do 2 pocket, because I'm substituting in for x, 6 plus y equals 42. Now, 2 times 6 is 12. Didn't use my y, so I'm going to bring it down. Equals 42. If I subtract 12 from both sides, I'm left with y equals 30. So my solution set here is 6 and 30. Let's go back to our question. What is the total cost of one hat and one golf shirt? Remember, the x variable, we're going with the number of hats. So the cost of one hat is $6. And of course, you need to write this in complete sentences. And then the golf shirts were with the y value in our systems, and that's going to be 30. So the cost of a golf shirt is $30. Okay? Now, what do x and y represent in this systems? We sort of already answered that. X represents the number of hats. And likewise, y represents the number of golf shirts. The number of golf shirts. And again, that's just matching up my values to my equation. So 1 to 1 for my y to y, that's going to be golf shirts. If the system of equations is graphed in a coordinate plane, which means a graph like this, what are the coordinates of the intersection of the two lines? Well, we already answered that because this was our solution. So it'll be 6, 30. What is the total cost in dollars of order C? Now, what I have here is 4 hats and 2 golf shirts, and I don't know what the cost is going to be. So I can write out a systems that's literally going to look like this. But I can fill in what x and y are to figure out what the cost is. So the cost of one golf shirt was $6. So I'm going to plug 6 in for x. And the cost of one golf shirt was $30. So I'm going to plug in 30 for y. Now, 6 times 4 is 24. 2 times 30 is 60. If I add 60 and 24 together, that's going to give me $84. So the cost of order C is $84. All right, guys, a lot of information there. Let's go ahead and practice.